Thank you very much. I would like to thank very much the panel of this profound society, and I'm happy to participate in this meeting. And especially, I would like to thank
more close the.
Okay. Yes, Professor Livia Giuliani for the invitation to come to this very, very interesting meeting. And I would like to talk on the topic which I was suggested by Professor Giuliani on the theoretical biology of Erwin Bauer and the living state of matter. Though initially I gave a little different name to the talk, living state of water. And in this respect, my talk somehow has something to do with the previous talk, which I liked very much, of Dr. Nikolai Blom. Okay, I would like first to start from the state of art now. According to current biological textbooks, which we teach, which we teach our students, and we were taught ourselves, it is written that sun is the major source of energy on Earth, and biosphere is open system, which is correct in respect to free energy provided by the sun. So the functioning of biosphere and all living things is considered to be thanks to high density energy of light, which falls upon green plants and produces and induces photosynthesis, and organic molecules are produced together with oxygen, and organic molecules are burned in cellular respiration in mitochondria. ATP is produced. ATP powers the most cellular work. Again, CO2 and H2O originate. So, and the whole this system rotates like it should rotate. Next slide, please. I cannot. Okay, yeah. Like it rotates in a machine. This concept, which is to which we are so much accustomed, assumes that living systems are essentially passive machines which are driven by external forces. The external machine gets high potential fuel from outside, performs work, and also dissipates some part of energy as a low potential heat energy. Though this concept do not explain many biological phenomena, of some of which Nikolai Blom told in his talk. For example, if we go very far from the sun to the bottom of the ocean, there is a complete darkness. There it is very cold, and oxygen concentration is very low. And still, though it was discovered probably only 2-3 decades ago, the deeper we go, life doesn't disappear. And life, very, very active life, and very big animals, in fact, fishes and octopuses here, you can find there, which are fed by no sunlight at all, no organic molecules which are obvious there at all, a very small concentration of oxygen, and still these animals are very active, and they convert the low density energy around them into high density energy. And here I even gave the picture of a squid which is bioluminescent, which produces a lot of light. By the way, it is very interesting that there is such a phenomenon as bioluminescence. The deeper you go into the sea, into the ocean, the more and more bioluminescent lighting animals are you can find there. So the animals can convert low-grade energy into high-grade energy, including work and even light. So the major concept which we teach and which we were taught, that living systems are machines which are driven primarily by the external forces, may not be completely right. What is the alternative to this concept? Alternative is that living state is the intrinsic active state of a specific substance, which we often use this term, living matter. And this living matter is extracting energy from its environment and converts this energy into work. This idea was pronounced by several scientists which were not in mainstream, but one of the scientists who made from this idea the whole and very consistent concept, which he called theoretical biology, was Erwin Bauer. His life was very dramatic, and Professor Giuliani already told a few words about this, and I hope that sooner or later some probably movie will appear about his life as a thriller. This scientist, he was a medical doctor initially, and then he turned into the theoretical biologist. He formulated the fundamental principles, axioms, on which he based the general theory of living matter. This general theory of living matter was published as a book named Theoretical Biology in 1935. This book attracted a lot of attention in Russia, unfortunately only because it was published in Russian language. There was a lot of discussions, but for very few period of time, because this time, 1930s, 1937, were most dramatic in the history of the Stalin Soviet Union, when thousands or hundreds of thousands of people were without any fault arrested and executed. And Erwin Bauer, unfortunately, he published his book in 1935. He was arrested in 1937, and he was executed together with his life in 1938. And the book disappeared practically from all the libraries, from circulation, and only very few copies of this book were left in the closed libraries. And when I was a student of the Faculty of Biology, he was already rehabilitated, and I had an opportunity to take this book, Theoretical Biology, from the library. I had a very good teacher, Erwin Schnoll, who studied the history of Erwin Simonovich Bauer, and who told me that this Bauer is a genius, and he really founded the theoretical biology. We, together with Emilio Del Giudice, published a paper in the journal Water, which is edited by Professor Pollock, and here is the reference to this paper. So my next talk will be a very short synopsis of what is theoretical biology according to Erwin Bauer, though it was devised in the first third of the previous century. It is not outdated. I think it needs to be introduced into the biological thinking. Okay, what is the major, what are these principles from which the biological theory or explanation or prediction why living things behave like this and not in a different way, why they are not machines? The first principle of Erwin Bauer, which he called principle of stable or permanent non-equilibrium. And here is the formula of this principle. All and only living systems are never at equilibrium. at the expense of their free energy, they ceaselessly perform work against equilibrium demanded by the physical and chemical laws appropriate to the actual external conditions. So it is, this formula seems to be a little complicated, but in few words, what is the difference between non-equilibrium, non-living things, like machines, for example, and living things? Because according to Bauer, they are non-equilibrium and they persistently perform work in order to stay non-equilibrium, in order to stay alive. Here is the difference between living and non-living. And the only work which living things are producing is the work to stay alive. They do not produce any other work, work for somebody else, so to say. If they produce work for somebody else, also in order to stay alive. And on another picture, on it's a little just jokey picture, that non-living things also can be non-equilibrium, they move and so on, but under the action of the external force. So they are never at equilibrium, and they have free expanse of free energy. So what is to be not in non-equilibrium? According to Erwin Bauer, a non-equilibrium state of living things is non-equilibrium state of their living matter. Stable non-equilibrium state is displayed at all the levels of living system organization, including the molecular one. Even at the molecular level, living things are also not equilibrium. The analogy of this non-equilibrium state of matter for non-living things is, for example, the working body of a laser. And laser is pumped externally by some external force. Its atoms and its matter converts from ground state into excited state, and this excited state is permanent non-equilibrium, though metastable. Then it can transform back into ground state, and this energy, which is non-equilibrium state, is released as free energy, and in principle it can perform work. So according to the principle number 2, all the work performed by living systems is produced at the expense of structural energy, or energy of excitation, better to say, of living matter. They convert into ground state, but then they should somehow return back into excited state. So it is not fuel which is somewhere outside these systems, which switches on all their functions. It is their matter which is excited and de-excited. So this principle number 2 explains how the principle number 1, principle of stable non-equilibrium, is performed in living things. And the third principle, living things are not stationary. The major biological process is the process of development. All life starts from the ovum and converts into higher level of organization. All life on Earth started from more primitive organisms, and they convert into higher and higher organized organism, what we call evolution. And according to Erwin Bauer, the third principle is the principle of increase of external work performance, because this excited state of matter, of course, it performs work in order to sustain in non-equilibrium state, but in order to sustain in non-equilibrium state, it should extract energy and matter from outside, convert it into its non-equilibrium state, and during development, this capacity increases, And during development of the biosphere, this capacity of the whole biosphere increases. By the way, as a matter of fact, though Erwin Bauer mentioned that his third principle is very close to the concept of Lamarckian evolution, which is directed, which goes from, by definition, from more primitive state to a higher and higher state. And what is interesting, I would remind you, that for the whole 20th century, Lamarck ideas of evolution were practically rejected by the school biology and university biology. And during the last 15 years, everything converted into the opposite situation. Now, if you look at the mainstream biology, it turns very, very fast into Lamarckian biology. So the third principle of Erwin Bauer, 1935, it was the Lamarckian principle, which was based on this excited state of biological matter. These three principles, which were postulated by Erwin Bauer, the principle of stable non-equilibrium, the principle of structural work performance, that is the excited state of living matter, and the principle of increase of external work performance, the principle of directed evolution, are the foundations of his theoretical biology. It is a very complex book, I would say, but I hope it will be translated sooner or later into English and will become one of the major courses at the faculties of biology. And these principles underlie the realm of all biology, because from them all the manifestations of living state can be deduced. But I would say that we don't know about these principles, and they are not so popular now for a few reasons. One of the reasons is simply nobody knows about this. But another reason is that Bauer did not and could not specify the nature of living substance, because according to him, this living substance is able to convert from ground to non-equilibrium state, to reside in non-equilibrium state, to fall down to the ground state with the release of energy which is able to perform work, and to recover back into stable non-equilibrium state. So what is this living matter? He was talking about living proteins, but this was already rejected, or living nucleic acids, which you didn't know at that time. But that was already rejected by biochemists who say that, okay, protein is just a chemical molecule, it is natural state is ground state, and so on. So, in fact, the problem until recently was of the essence of this living substance. What is the material basis of the living substance? And here I will repeat a little what was told in the previous lecture of Nikolai Bloom, because the material basis of living substance, as we begin to understand now, it is water. So long before us, the founder, I would say, of modern biochemistry and the founder of bioenergetics, Albert Szent-Györgyi, said prophetic words that water is mother and matrix of life. And Nikolai already mentioned that water is, by molecular count, is 99%, even more, of all molecules in our body. But I like to always give such an example which is more obvious. What is on molecular basis? We like the weight basis. And there are such animals, hydrobionts, like jellyfishes. There are jellyfishes which consist on weight basis of water on 99.9%. That means that I am the professor of the Department of Bioorganic Chemistry. What we study is only 0.1% by weight of all living things, and 99% is water. And here is the picture of the jellyfish, which is even shining. So jellyfish is living things with all the properties of living things, with instincts, with it's able to multiply, to feed, to react, to attack, and so on. So it is alive. From this it follows just very simple logical conclusion that a system containing essentially water may reside in permanently excited living state. In permanently excited living state. So it is highly energized. And what is the major source of energy in all living things? It was the answer to the question was given more than 200 years ago by Antoine Lavoisier. He said that the major source of free energy for living system is respiration. And respiration he defined as slow combustion of carbon, oxygen, and hydrogen, similar in every way to that what takes place in the lighted candle. And of course, he was right. In this respect, he said that breathing animals are active combustible bodies that are burning. The modern biochemistry converted this saying of Lavoisier into the mitochondrial respiration with the slow, so to say, release of energy when electron falls along the phosphorylation chain and so on. But we said that most molecular stuff of living things is water. And in fact, the question is, was Lavoisier right? Is water the source of energy? And can we answer these questions? So what is combustion? Combustion is direct oxidant reduction with electrons or hydrogen that may be accompanied with photon emissions, with flare. That is combustion, that is burning. And in fact, so here is just the scheme, a chemical scheme of combustion. And in fact, it turned out also very recently that from 20 to 90% of all oxygen in our body is consumed, is utilized in the process of direct oxygen reduction. I give only one example. After egg fertilization, the beginning of every individual life, the respiration rate increases 10 times, and all the oxygen is directly reduced with electrons using not mitochondrial respiration, but such enzymes as ADPH oxidase and so on. And the fertilized egg really shines. It emits a light. We could observe it in our experiments. And so, in fact, what has this combustion to do with water? If to look into the literature very deeply, one can find that water is the catalyst of combustion. And this was described, it may seem strange, more than 200 years ago. It was discovered by the British chemist Elizabeth Fulham in a book published in 1794. That without water, there is no burning of coal. Without 100 years later, it was shown that without water, there is no burning of many, many other things. So even traces of water are needed for combustion, for burning. And in fact, this combustion was demonstrated of water. It was demonstrated already in this century by first by the American inventor John Canzius, and then it was confirmed by the physicist Rustum Roy, that if you take salt water, just a little salt water, and you put this water under the action of the radio waves, then this water and give a spark, then you will see the flame. This water will start to burn. and the temperature of this flame which appears from this burning water reaches 1,500 degrees. So how to explain that water is burning? Burning of water is donation of electrons to oxygen. So it means that water may split into hydrogen and oxygen, and hydrogen atoms, they combine with oxygen of the air and oxygen which is released from water, and they can burn. So how can it be? When COMBUSTION discovered it, when it was discovered at the end of the 19th century, when it was discovered at the end of the 18th century, people couldn't believe it, because we know the common knowledge that water extinguishes fire. And on the other hand, it turns out that water can be a fuel. So why water behaves so paradoxically? And here, in order to explain this paradoxical behavior of water, I need to give the names which were already pronounced in the previous talk by Nikolai Blom, that it was first theoretically predicted that real water is never homogeneous liquid. It is always a multi-phase complex system. And any water contains organized coherent water and disordered blank bulk water. And this follows from the theory of water developed by Emilio del Giudice. From my point of view, it's one of the greatest physicists of the last century, together with Emilio Preparata, where they suggested the theory of water, which is based on quantum field theory. From their theory, it follows that water contains so-called coherent domains, which are different from bulk water in which they are suspended, and there is potential difference between coherent domains and bulk water, and the process of water oxidation can go even in theoretical water. So the theory was never rejected, but it was not, until now, I suppose, probably I'm wrong, it's not accepted by the academic physical community. Though sometimes after this theory was formulated, Professor Gerald Pollack and then other authors had confirmed that water has unique properties, and these properties which they discovered support Preparata del Giudice theory. When we are talking about water, we are talking always about complex systems. There is no abstract water of some substance which consists only of molecules of H2O. Water always contains some dissolved stuff in it, but it's what is not less important. Water is always in a vessel, and there are boundaries in this vessel, and water very often has a water-air interface, and this water-air interface is also different from water in the bulk, in the volume. And Gerald Pollack, during 15 years of his research, he demonstrated that water phase adjusted to hydrophilic surfaces, exclusion zone water, because it excludes everything which is doesn't fit into its organized system, is different from bulk water in majority of physical and chemical properties. And he called, already Nikolai mentioned it, this water exclusion zone water as a fourth phase of water: liquid crystalline, quasi-polymeric, and coherent water. What does it have to do with the excited state of biological matter? Protons are expelled from this low entropy interfacial water, and this water is charged negatively. So what it means that it has excess of quasi-free electrons. And there is a potential difference, electrical potential difference between this water and bulk water. If you put two electrodes between these two waters, then the electrical current flows from this interfacial water to bulk water. But also what is no less important is that this water is the source of electrons, and oxygen, always present in water, is the acceptor of these electrons. And interfacial water, in this sense, it converts into fuel, which may be oxidized by oxygen. So it is a kind of a fuel which can burn. And here is the very straightforward equation. When you have water, this interfacial water, and you have oxygen, in principle, it can be oxidized, and a very paradoxical reaction can go on. This reaction is conversion of one water into another water, because the products of this reaction chemically are the same as the substrates of this reaction. But as any burning, this burning gives energy. What happens? The intrinsic source of this free energy is transformation of dynamically structured, of coherent water into disorganized bulk water. Structural energy may transform into useful work. We burn water and we get water, but we burned highly organized water and we get disorganized water. Entropy of the system increases, and due to increase of entropy, we gain free energy and we can perform work. But another quasi-miracle, it's not miracle, it's already new science, that due to ambient radiation, which we cannot shield our system from this radiation, it's infrared radiation in the first place, this bulk water, which is disorganized, it again converts back into highly organized, coherent water. So we have this machine which produces work, and then it restores its initial state. So from this, we may say that this water, which is any water in this bottle or water in our body and so on, it is a converter of the dissipated free energy of infrared energy from around into high density energy in a sense of energy of life. So this is just a theoretical approach to this problem, and can it be observed in real systems? In fact, the process of water burning may be catalyzed. And the catalysis of this water, as we have demonstrated, can be performed by different substances. It can be performed by external electromagnetic fields, which, for example, Livia Giuliana is studying. But one of the most abundant catalysts of water burning are carbonates, which are practically present in everywhere, both in our body and both in the environment. So carbonates are catalysts of water burning. And we know also very well that carbonates or bicarbonates are also the universal remedy. If there is decrease in bicarbonate contents in the body, there is suffocation. People may die even in the abundance of oxygen if the bicarbonate concentration goes too low. So what it can be demonstrated that if you take a bicarbonate solution, for example, solution like this, and in order to boost burning of this water, one may add hydrogen peroxide, very small quantity of hydrogen peroxide to this water. And this water begin to emit photons. We made hundreds of experiments like this. I give you just only one example. You take this solution of drinking water, 5 millimolar bicarbonate activated with hydrogen peroxide. You put it into the test tube, which is hermetically closed, and this test tube emits light. On this graph is shown the curve of photon emission from this test tube. This photon emission lasts for, at least in this experiment, for a year and a half. So that is the lamp which do not switch off practically. Why? Where from does it get this energy? It gets this energy from outside heat and converts it into light. So we are coming to such a conclusion that aqueous systems in which liquid crystalline water and quasi-chaotic bulk water coexists, and these are practically all liquid systems which we have in our environment and inside our body, where charge separation between two phases is ensured. That means that there are surfaces which convert water into the electron donor. And where coherent water is provided, for example, by catalysts or ambient radiation, they can transform external low-density energy into organized, coherent, free energy. So such liquid systems meet all Bauer's criteria of living state. So they permanently exist in non-equilibrium state, and they use all their energy in order to sustain in this non-equilibrium state. And the final slide, that the necessary condition for such system functioning is availability of enough low-density energy, thermal or infrared energy, and when we have enough infrared energy outside in the environment, then we have liquid water. And that is enough in order to separate one water from another water, bound water from ambient water. And so that means that the first condition for life is that water should not be ice. It should be liquid water. That is a very simple condition. It should not be also vapor. So these are the boundaries for life which are very well known, from 0 to 60, 70 degrees, something like this. And the same condition is needed for the spontaneous emergence, because when you have ice and when you melt this ice, immediately you get this miraculous substance where you have charge separation, where you have oxygen and so on. And for its existence, for its self-organization, because this substance, this liquid water, is from the physical point of view, it is excited state where the atoms of molecules of nitrogen, of carbon, other molecules convert into the chemically active state, and they begin to interact with each other. So this self-organization and development is provided for all living systems in the forms known on Earth. So I came to the end, and I would say my conclusion, I would say a little philosophical conclusion, is like this. Whenever in the universe we find liquid water, life is necessarily should be present there, and it should have all the physical and chemical, probably not morphological features which we study here on Earth. And that is based on the Bauer's theoretical biology principles and on the properties of the living water. Thank you very much.